Okay, so today I'm going to discuss about a very useful data type in Python that is called a list. And today's video will contain these points about the list. First, I will talk about the list, how they can be indexed, how the slicing, concatenation, extend, append operations can be performed on the list, what is meant by the mutability of a list, and what is meant by the aliasing and cloning in a list. And then I will give a short Google Colab demo in which I will be demonstrating the points I will just elaborate in the slides. So first of all, what is a list? A list is an ordered sequence, and what do we mean by an ordered sequence is that we can access the elements of the list in a specific sequence or by a specific indexing. For example, consider this list might, and here you can see that there are 3 elements in this list. One of them is a string, then a floating point number, and then an integer. Likewise, there is my list 1, where you can see again a string, floating point number, a number, then another list inside it, and then there is a tuple inside it. How we distinguish between a list and a tuple is that in Python, tuple is enclosed inside these parentheses, and a list is enclosed inside these square brackets. So this is how the Python interpreter will identify a list, or it will distinguish a list from a tuple in its syntax. So the elements of a list can be accessed to its indices, as we saw in the video on tuples. There are 2 kinds of indices. One of them is the positive indexing, and the second one is the negative indexing. For example, consider the case of the my list, in which we had these 3 elements: data science 10.1 and 2024. And if we are making use of the positive indexing, then indexing start from 0 and it goes to 1 less than number of elements in the list. So in this case, there will be 0, 1, and 2 index numbers to access these elements in the list, which are data science at index 0, 10.1 at index 1, and 2024 at index 2. So if I want to access individual elements, I can make use of this notation of square brackets and specify the index at that particular location. For example, if I write my list, which is the name of this list, and square brackets contain the index, which is this 0, and I will get this colon notation I am using as the output, which is not basically the Python syntax. In fact, it is just used as a notation or a convention on the slides to show the output of a specific operation. So if I write my list 0 inside the square brackets, I will get this output on the console of the Google Colab terminal, or any IDE which I am using for my Python coding. In the same way, my list 1 will give you 10.1 and my list 2 will give you 2024. So in Python, you can make use of negative indexing, and in that case, the negative indexing starts from the right end of the list. In this case, 2024 will have the negative index -1, 10.1 will have the index -2, and data science will have the index -3. And just in the case of positive indexing, you can make use of the square brackets to retrieve a specific element at a specific index, which in this case is a negative index. For example, if I write -3, my list -3, I will get the output data science. And in the same way, my list -2 will give you 10.1 and my list -1 will give you 2024. And as in the case of tuples, we can also perform a slicing operation on the list. In this case, if you have this list, my list, which has 3 elements, and I want to do get a slice of this list, so I can perform that by giving 2 index numbers. For example, if I give 1 and 3, it will mean I will retrieve the elements at 1 and 2. So it will be 1 less than this, the upper bound. So in this case, I am going to retrieve the elements stored at index 1 and 2. So that will be the result of this slice operation. Like tuple and string, we can also concatenate lists. So in this case, for example, if I have the given list, my list, which had those three elements, and I want to concatenate this other list which has Python 11 in it, so I can create a new list and then make use of this concatenation operation, in which I can pass 2 lists, and those will be concatenated in the variable which I am going to use to store the result of the concatenation. So in this case, my list 1 will give you the output this. And I try to print out the contents of my list 1. So now this was the my list with which I started. Then I want to make use of the concatenation. So the concatenated part or the concatenated list will be concatenated at the end of this list, which will now become the resultant mylist1, which has the elements of both the list mylist and the list I passed to the concatenation operator. Another very useful operation is the extend. So in this case, I don't need to create another variable for adding elements to an existing list. For example, I have this given list which has 3 elements, and if I make use of the extend operation, I pass this another list. So in this case, my list will be extended with 2 elements. So what does it mean? These 2 elements which are given in this list will be stored as separate elements of the resultant list or the list formed after that. So the result will be my list will be having elements data science 10.1 2024 Python stored as a separate element and 11 stored as a separate element. So if this was the original list, and the after extend operation, the 2 elements will be added at index 3 and 4. So this is my list extended. Similar operation is another one called the append operation. So if I want to invoke the append operation, what happens is that it will not create 2 different elements. It will append this parameter passed to the append method as a separate element to the list, which is the my list in this case. So my list will have now 4 elements, and at the third index 0, 1, 2, at third index it will have Python and 11 stored in it as a list. So a list can contain different sorts of data types. It can have strings, integers, floats, other lists or other tuples, and so on. So now in this case, I had this list originally, and I want to append another element, which is a list. So I can make use of the append method, and it will be stored at the next index of the list. So it is also possible to modify values to the indices of the list. This means that the list is a mutable data type. For example, if I want to change the contents of the first index, I can just access that index to my list 0 and assign it a new value, which in this case is Python. And after this operation, when I try to print my list, then the first element or the element of the 0th location will be changed to Python instead of data science. So, likewise, we can also delete different elements from the list by making use of the del command. I just need to pass a specific index, and the contents of that index will be deleted when I invoke the del command. So if I deleted the 0 index, no, then the Python or data science, whatever it was, it will be deleted, and the remaining 2 indexes will be elements of the remaining 2 indexes will be shown. A useful operation in case of list is the aliasing operation. So what do we mean by aliasing? For example, I have a variable of type my list, variable of type list, which is called my list, and I assign it to another variable. So in this case, these 2 variables will be referencing the same object, which was a list created or used earlier, that is Python 10.1 and 2024 elements in it. And now what can happen is, if I try to change the elements at one location in one list, for example, I want to change my list, which is this first list, I try to change the index at 0 to Java, then it will have a side effect. What does it mean is that my list 1, 0 will also be changed to Java, because both of these are referencing the same object. So in this case, the referencing since they are referencing the same object, so the effect will be visible in both the variables when we change in one. If we want to avoid this, we can make use of the cloning operation. And what do we mean by that? In this case, I create a new variable and I make use of the first list, which is this one, and I just passed a colon inside this square brackets, and it will create a clone. And what do we mean by that? Now in this case, both these variables are having their own copies of the list, and if we change the contents of one list, those will not be impacted or reflected in the other list. So cloning is useful when we don't want to have the effect of one list on the other list. Okay, now we switch to the Google Colab demo Python list. So now let's start with the list demo. So let's have my list equal to, let's say, Python and 11.5 and let's say 25. I want to this list. I just need to write this and I will see the contents of the list. Now if I the contents of the list, for example, if I write make use of the positive indexing, I can print the contents at index 0. That will be Python. Likewise, if I write Python 1, then I will see 11.5. If I write -1, then I will see 2025, and if I write -2, then I will see 11.5. So we can also slice the list. How we can do that? For example, my list 1 is equal to my list. For example, I want to see the last 2 elements, and now I want to print. So there you see the last 2 elements in this list. You can also concatenate a list. So for example, I have this, I want to create my list and I want to concatenate my list plus another list. For example, I pass it Java and 25, and now I want to see what is in my list 2. There you see Python 11.5 to 25 and the last 2 elements which we concatenated with list, we just see in the output. Now again, if I want to see what happens when we try to extend this list, my list, let's do this to see the effect of my list dot append, sorry, extend. I want to pass these 2 elements, this is Java and 25, and now I want to see what happened to the list. These 2 elements will be added to the existing list. Here you see again Java and 25 have been added. But if I want to pass another list inside this, now what happens is Java.25 will be added as a list in this one. So I already have Java 2015, Java 25. So I will see a list inside this. Here you can see that here Java 25 has been added. Now to see the effect of the mutability, and what do we mean by mutability of a list? For example, I want to change the first element, which is Python, to Java, and now I want to print what is inside the list. I again invoke the list variable. Here you see the first element has been changed to Java. Now if I want to delete some element from the list, so I just need to invoke the del command and a specific index on which I want to delete something. So I again invoke this my list, so I want to see 11.5 removed from it. So you see that there is no 11.5 in this list now. To see the effect of aliasing, so I create another variable called my list 2 and equal to my list, and now I change, for example, I say that del, here first I print my list and then print my list 2, and now I change my list dot extend, for example, C++ and 21. Now again print my list and print my list 1, sorry 2. Now we want to see the effect of these. So here you see I just changed in my list, but the effect is visible in both of these. If we want to avoid this, then we need to create a clone. And what do we mean by clone? I can do that by putting a square bracket here. And for example, now I change this to, let's say, Ruby and 27. 27. So if I run this again, so I will see Ruby 27 in just one of the list, which is my list. There you see. So the first one was my list. So Ruby 27 has been appended or added in just one list because of this clone operation and not in the other. So cloning preserves the copies referred to by these variables which we created. And if we don't use the cloning operation, then the side effect is visible in the other list, which is not directly accessed. So that was all for the list today. I will be describing the dictionary in the next video. So till then, thank you and goodbye.